Hello, I will try to explain here in this video how I implemented the ROS Nodelet with OpenCV and OpenCV Bridge using YOLOv3. So basically, if you follow the ROS wiki, um, Nodelet is basically a plugin that it has also another capabilities. In example, a ROS Nodelet can run several nodes, and basically this nodelet publish all the information using uh, pointers. That's the advantage. It's like zero memory passing lag for other nodelets and applications and the topics also. So uh, to explain here a simple nodelet or a simple plugin. For example, here I made the simple plugin here. Let's see what is inside the package .xml. Here I only used the plugin lib, the ROS CPP to do a simple plugin. Next, I did um, a class for a rectangle. Here is the class implementation. And in the source, you will have to do two things. You will have to load the nodelet. Here is the class for loading the nodelet. And also the implementation of the how we load the plugins. So here we load the plugins for those two functions inside the classes. I mean the classes basically, because we have two classes as I told you. We have the class for a triangle and the class for a square. When you have all those things, you need to implement a plugin nodelet. I mean a plugin XML that contains the base class and also the type of the class. When you have all those things upon working, you can build the package and launch the file using you you can use the ROS run, or you can implement a launch file. I use ROS run because I don't have here my launch file. But basically, this is the main concept. A nodelet is built in a plugin. So for the object detection, I based it on the OpenCV apps. That's why you have here my configuration of threshold and the YOLO. Let's open directly the YOLO configuration. Here, just only I made the configuration for YOLO using camera info, and also if you want to check with dynamic reconfigure the confidence threshold and the non-maximum suppression threshold, because the confidence threshold will give us, for example, how much the network is certain about if it is inference object. An example is if it is a person, how much percent we are sure that that the network will predict that it's a person. And the non-maximum suppression threshold will suppress all those bounding boxes that YOLO generates and are not for the object. An example, probably object is detected but have also another detections over it, so the non-maximum suppression will eliminate all those non-necessary boxes. So here I exit and generate the dynamic reconfigure package. Next, let's see what is inside of this file. This file is, as I told you, is the implementation of the node using OpenCV apps. So you have to do include file here, and also let's jump to the launch file. The launch file have only the node name. I'm publishing to the Jetbot camera image raw, so that will be my image. Those are arguments only. Use camera info, debug queue, queue size, and And that's are the interesting arguments. I'm using the YOLO configuration that is on the folder object detection.yolo, object detection YOLO, and those files are downloaded from the repository of Joseph Redmond. So you have to only get the weights. I supply to you the names or the labels and also the configuration. You only have to get the weights. So go to the web page of Joseph Redmond, and there explains there how to download their weights, because this weights file I think is around 300 megabytes. Well, these are the configuration files of YOLO. This is the weight file, and this is the labels. As you see, I'm finding this folder and navigating until I found those files. This is my confidence threshold for the object is 0.5, and the non-maximum separation for the bounding boxes that is 0.4. And by default, the input width and input height of the YOLO image will be 416 for 16. That's because the network was trained on that thing, but you can also modify to get another different results. Remember that if you are inferencing, you need to have the batch size and the subdivisions to 1 in the configuration file. Next, on the source file, on the source files, you need to create a folder named node. Put this file that is basically the nodelet manager, will spawn all the nodes that will be launched. Also, we have a folder named nodelet that will have the basic implementation of the nodelet, and also my implementation of the YOLO v3, but basically my implementation is based on the learnopencv repository. I will explain it a little bit. Let's go to see about some things. Those are the common headers for OpenCV and CV Bridge. Also know that we are using image transport for publishing. We need to I'm also doing dynamic reconfigure, you will see later. Here I have the input file string. This is for file manipulation only, and we're also using the deep neural network module, using the OpenCV DNN to short the calls of the functions. And here we implement the object detection network, some variables. These variables here are for the YOLO, the configuration file, the weight file, the names file to store it on memory, just only the names, right? On memory. These are the confidence and non-maximum separation threshold, input dimensions of the image. This is for storing the class labels. Here for making the use of the OpenCV DNN module. Also, how we store the model configuration of ways or load it at least. But let's start with the code that starts below. Here, when you when the nodelet manager called the nodelet, initialize the nodelet, get some parameters, also gets the configuration of the YOLO network, the weights, names or labels, input width and height. If you see, I'm using dynamic reconfigure for just this, well, is below the parameters that I'm using for dynamic reconfigure. Next, I load the class file by line, and also I configure the deep neural network for future inference. I'm using the OpenCV and the CPU to make inference. I'm not using GPU. And here for dynamic reconfigure, as I told you, I am only using 2 variables. And finally, I am publishing the image topic. Next, when everything is working, we will load the image. Next, make a blob. The blob is an object to pass to the network practically. So here I am scaling the image from the input dimensions to 416 to 416, and also we normalize the image because it's necessary, and it is in the paper that we need to normalize the image. It's just for that. We have to get values between 0 and 1. Next, I'm using the blob to set the input, make the inference, and finally post-process the image to just put the label and some sort of things. Finally, I'm showing the image. If you want, you cannot display it. And also, I'm publishing the image to the CV bridge. So what are other things like this post-process function? Well, this post-process function gets the frame, and it will out all the confidences. As you see here, we are getting in the frame and looping, making all get all the predictions, and starting on the class IDs array, the confidence array, and the bounding boxes for each detected object. And in the end, we are doing a non-maximum suppression for every detected object and draw the predictions. And the prediction is only the label of the object. So here below is the draw predictions. The draw prediction is drawing a bounding rectangle and also putting a label here. It puts the label. Next, this function is just only for getting the name of the output layers, and those are callbacks for making the inference. Well, the part here is the plugin. You see that I explained later that before that these nodelets are basically plugins, so you need to register all the plugins. And in the plugins here, I have my threshold plugin registered just to register it because I am not using it. And also I'm using my YOLO nodelet. Here are the package docs.xml. As I told you, the CV reach, mass transform, nodelets, ROS standard message dynamic reconfigure. And what else? On the CMake list, I'm just finding those packages that I mentioned before. I also am finding OpenCV that is required to build this package. Here are the dynamic reconfigure parameters. Also, here is my YOLO configuration I explained before. We need to include from which package king depends. Also, we need to include this directory. Here, the include for the nodelet. And also, here is a simple macro that will add a nodelet to the application. I'm using 2 nodelets, threshold that I'm not calling right now, and the YOLO implementation. Finally, we add the library, add the dependencies, and add the target labels. That's all. So just to check how to load it, because I have a different video that um, shows how is loading the application. But basically, we launched the Jetbot differential drive with Gazebo, and when it's loaded, because it's publishing all the joins and all the things, we have here the empty world with a code can and a soccer ball, also the RQD steering uh, window. And next, we will launch the YOLO Nodelet, and this will uh, launch a window here that at, at the first time we'll try to load all the labels and the model weights, and it will take a little bit of time. But in the end, you will get an image. Of course, it's not inferencing the code because it's not on the neural network, and we can rotate here using the RQT, or we can rotate it with the Gazebo tools. So we will wait a little bit because I'm using the CPU for inferencing. And here we are. Obviously, this is a simulation. It says kite because the network confuses if its dimension is not well defined, but if you make some light conditions here, it will be better. It's because on the implementation of YOLOv3, once it was not trained for a synthetic image, but it will try to do its best. And let's try to at least move a little bit, maybe back, to see if inference the soccer ball. Okay. Showing. Let's move it a little bit. So the application is not failing. It's basically how we train neural network. At least it's making object detection and detecting the object. It depends also, I told you, on the illumination. Also, the model has these lines that probably confuses the network. But in my previous video, I explained and I show you that the application is working. And also, uh, you can train your neural network based on YOLO to try and do some inferencing based on all synthetic images, because it will work better than just only viewing the gazebo here and try to inference at time. Basically, the inference time is around 2 and 3 seconds, and it will try to do its best. Let's move it here to see if at least try to change the inference. Here is but it depends. It depends of the network. The network gets confused and do some strange things. It thinks that it's a cat. It's a kite. Sometimes I view that it says that it's an elephant. So it depends on the illumination and the position and some sort of things that are inside all those neural network inference and prediction. And at least it's working. Okay, that's all. If you have any questions, just contact me by my social media or get me an email. All the information is on GitHub. So thanks for watching.